Now we're going to look at parallel lines cut by a transversal. But first of all, before we talk about parallel lines cut by a transversal, let's just talk about lines cut by a transversal to identify some parts. Now, if you look, I've got a little diagram here where we've got, you've got a line here, another line there, and this thing right here, this is called the transversal. So you have two lines cut by another line that goes up through it, and those are called, that's called a transversal. Two lines cut by a transversal. Now, just to identify some parts, you notice that above this line here, this line, whoops, slid it over. Above this line, I've got this angle and this angle. In other words, I have to the left of the transversal and above the line. That's angle 1 and angle 5. Okay? To the left of the transversal and above the line, I have angles 1 and 5. Now, so we would say that angle 1 and 5, those are corresponding angles. Now, those are not the only corresponding angles. And if I ask you, well, what are the other corresponding angles? Well, you would say 2 corresponds to 6. Okay? Obviously, those they correspond to each other. Those are to the right of the transversal and above the line. And just in general, if two angles are corresponding angles, if they occupy the corresponding positions. So you can see angle 3 and angle 7, those are corresponding angles. 4 and 8, those are corresponding angles. So it's pretty intuitive which angles are corresponding. Now, there are what we call alternate exterior angles. You notice that if we talk, we've got interior. So if you look at the interior of this thing, okay, this is interior, and these right here are interior angles, 3, 4, 5, and 6. They're kind of they're between the lines. Now, if you think about exterior angles, well, you've got angle 1, angle 2, angle 7, and angle 8. Those are they're outside. They're exterior angles. And in fact, we have what we call alternate exterior angles. So for example, look at this angle 1 and this angle 8. Those are both outside and they're alternate, right? One's on the left-hand side of the transversal, and 8 is on the right-hand side of the transversal. Okay. You notice also 2 and 7. Those are alternate exterior angles. Okay. So that makes pretty good sense. Now, let's look at alternate interior angles. Well, same thing, only now we're inside. So we have 3 and 6, 4 and 5. Those are alternate interior angles. And then we have consecutive interior angles. Okay, so this next one, consecutive interior. So 3 and 5. In other words, they're on the same side of the transversal. Okay, and in fact, sometimes they're called same side interior angles. But anyway, okay, so that's just some terminology. Now, what we're dealing with here, though, is we're thinking about parallel lines cut by transversal. So let's suppose I've got a line here, and let's suppose it is cut by a transversal. Okay, there we have it. And think about this angle right here. Okay. Now, what I want to do is I want to come down here and make a parallel line. And notice that this line here is parallel to that line. Now, I may as well have just taken this line and moved it down here. See? In other words, it's a parallel line. And notice my point is that this angle right here, these two angles are going to be the same. Okay? In other words, these this angle here and this angle here are going to be the same. So this pair of corresponding angles are going to be congruent. Now, I say that about those angles, but notice that these angles would also be congruent. Okay? Because the lines are parallel. Just like if I had taken this line right here and just shifted it down. Likewise, this angle, and this angle. And finally, these angles. Okay? Okay. So, right away, we've got that situation. Now there is a postulate down here. If two parallel lines are cut by transversal, then the pairs of corresponding angles are congruent. And that's what we just talked about there. The pairs of corresponding angles are going to be congruent. It has to be the case. Because remember the situation, I said I could just move this line down. And the angles, nothing's changed about it, right? So we call that the corresponding angles postulate. Now, these names, after a while you get all these names. You don't have to remember all the names. You can say pairs of corresponding angles are congruent when two lines are intersected by or cut by transversal. In other words, you just need to know the concept there. Okay, now, when it comes to parallel lines cut by transversal, we've got some theorems here. We've got alternate interior angles, okay? If two pair of parallel lines are cut by transversal, then the pairs of alternate interior angles are congruent. We have consecutive interior angles, okay? If two parallel lines are cut by transversal, then the pairs of consecutive angles are supplementary, okay? So this is 3.5. So these are things that we're going to use. Some of them we're going to be asked to prove. If two lines, so this is 3.6, whoops. If two parallel lines are cut by transversal, then the pairs of alternative exterior angles are congruent. And finally, the perpendicular transversal. If a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other. Okay, that makes really good sense there. Okay, now let's see here. We want to prove the alternative interior angles theorem. Okay, so we want to prove this first one right here, the alternative interior angle theorem. Okay, so we want to prove that angle 1 is congruent to angle 2. Okay, so let's see how we would proceed. Okay, so we've got our statements. Whoops. We've got our statement and our reason over here. Okay, now first of all, of course, P is parallel to Q. That's given. Okay. Now, let's see what else we know here. Okay, now remember, we want to show that angle 1 is congruent to angle 2. Now, what do we know here? We know that the measure of angle 1 is equal to the measure of angle 2. And we know that because corresponding angles. So the corresponding angles. The corresponding angles postulate. Okay, so we know that. Now, we also know that angle 3 is the measure of angle 3 is equal to the measure of angle 2. And we know that because vertical angles are congruent. Vertical angles are congruent. Okay? And, okay, so now I think was that one we, oh, that was the last video. I think we showed that. So, getting ahead of myself here. So, vertical angles are congruent. Therefore, okay, so look, we know the measure of angle 1 is equal to the measure of angle 2. Okay, measure of angle 1 is equal to the measure of angle 2. And we know the measure of angle 3 is equal to the measure of angle 2. Therefore, the measure of angle 1 is equal to the measure of angle 3. And that's we call that the transitive property of congruence. See, 1 is congruent to 2, 2 is congruent to 3, therefore 1 is congruent to 3. So this is the transitive. Whoops, it's that I there. Whoops. Transitive property of congruence, okay? So there, we've proven it. So angle 1 is congruent to angle 3, or the measure of angle 1 is equal to the measure of angle 3. I was using measures instead of congruence. But anyway, that's how that goes. We showed that 1 is congruent to 2, and that 3 is congruent to 2. Therefore, 1 must be congruent to... actually, I wrote this wrong, didn't I? This is 2 here. Yeah. 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 1 is congruent to 2. 3 is congruent to 2. Therefore, 1 is congruent to 2. And that's what we wanted to show. I wrote down the wrong thing, but anyway, I hope that was understandable. Okay. Now let's look at this. Let's look at this next one. Okay. So we're given. Let's see what we know so far. We're given that the measure of angle 5 is 65 degrees. So let me just write that down here. Okay. This is 65 degrees. Now, what do we know immediately from that? Well, we know that the measure of angle 6 is also 65 degrees. Because these have the same measure. Now, look, there's a bunch of stuff we know now. For example, angle 7, we know that angle 7 is supplementary to angle 5. So this is going to be 180 minus 65, which will be 115. Okay, so now we know that this angle is 115. Now, because that angle is 115, we know this angle is 115. So look what we've got. We've got 65 degrees here, 115 and 115. Okay, now let's see if we can figure out what angle 8 is. Okay, now let's think about how we could do this. Angle 8 corresponds to angle 5, right? It's below the line to the left of the transversal. So angle 8 is also going to be 65 degrees. And then angle 9 then is supplementary, and it's 115. Okay. Yeah. There it goes. So let's look at this. Let's just see if we can make sense of this. We've got two parallel lines cut by transversal, okay? And let's see if we can figure out, okay? So this angle and this angle are the same, okay? This angle and this angle are the same. Now let's see here, this angle is the same as it's a corresponding angle. This angle up here is the same. This angle, and let's see, this one would be that. Is that everything? I think we got everything there. Okay, so you can see how these work out. Now let's think about this. So let's look at a problem where we would use this information. It says use the property of parallel lines to find the value of x. Okay, let's see here. Now we don't have angle 4, do we? However, we know that angle 4 is the same as this 125 degrees, okay, because those are corresponding angles. So we know that the measure of angle 4 is equal to 125 degrees. Now, we also know this. We know that angle 4 and this other angle down here, we know that x plus 15 degrees plus 125 degrees, we know that that equals 180. And the reason we know that is because they're supplementary. Okay, so let's see what we have here. We have x plus 125, that's going to be 140. Like that. And then x is equal to 180 minus 140, that's 40 degrees. So it looks like we have that x is equal to 40 degrees. So this is so in this section we've got a couple of things. We've got, the little proofs that we do, and this is going to be typical of how we proceed through geometry. We cover a topic, we do a little bit of proof and some computations. Okay, so you can see how these computations are done. And down here in the assignment, you can see, you're trying to find angle 1 and 2 here on number 8, 1 and 2 on number 9. So you're just trying to use the properties of parallel lines cut by transversal, the angles formed, to answer some of these questions. And, I threw in a proof for you, okay, as a treat. Okay. All righty, let me know if you have any difficulties.